In this lesson, we're going to look at polynomials. We're going to define them, we're going to look at the different types of polynomials, their characteristics, and what makes different types of polynomials. We're also going to look at combining like terms to add and subtract polynomials. Let's go over to mathisfun.com to take a look at what a polynomial actually is. When you look at polynomials, you see that a polynomial is essentially just a collection of monomials or terms. Polynomial comes from poly, which means many, and nomial, which means term. So it essentially just means many terms. A polynomial can have constants, variables, and exponents. In this term, you have 4xy squared plus 3x minus 5. Notice that each of those terms are held together by addition and subtraction. That is one of the keys that you want to look for when you're looking at polynomials, that the terms are held together by addition and subtraction. You do not want terms that have division by a variable. So in other words, if you have division with an x on the bottom, then that would not be considered a polynomial. So a polynomial can have constants, variables, and exponents, but never division by a variable. So take a look at these examples. In the first term, you have 5xy squared minus 3x plus 5y cubed minus 3. Each one of those individual components are called the terms of the polynomial. That makes up a polynomial. But over here, you have terms that are not considered polynomials. This one is clear why it is not a polynomial, because it is being divided by a variable. And we said polynomials can never have division by a variable. And we have division by a variable right here. This one, however, is maybe not so obvious. I don't see any division by a variable there, but it says it's not a polynomial. I think you have to think back to your rules of exponents for this one. What is the rule when we have a negative exponent? We have 3xy to the negative 2. When we have a negative exponent, what happens to it? We have to change that, right? That becomes 3x y squared on the bottom, because in order for that exponent to become positive, it has to relocate to the bottom. So now what we have is division by a variable. And that means it's not considered a polynomial. So we would say that is not a polynomial. Here are some more great examples of polynomials. Notice how some have one term, some have two terms, some have 4 or 5 terms, and some have only one constant term. One term is allowed, 2 terms are allowed, 3, 4, 5, 6 terms are allowed. These all have special names, and we'll get to that in just a minute. One thing to note is that even just constants are allowed, and they are also known as polynomials. Here is a good list of examples of non-polynomials. Notice that each of these have a unique problem that keeps them from being a polynomial. In this case, it has a negative exponent on the y, and we just talked about what happens there. 3xy to the negative 2 becomes 3x over y squared, because any negative exponent has to move to the bottom to become positive, and thus we'll have division by a variable. In the next example, we have division by a variable, as is. The same with the third example. In the fourth example, we have the square root of x, which as an exponent becomes x to the 1/2, and fractional exponents are not allowed. We will also get to that later. In these examples, these are allowed. X over 2. This is a fraction, but notice that the denominator is not a variable. It is a whole number, not a variable. That is okay. The same goes for 3x over 8. The 8 is an integer, not a variable. That's fine. That is a polynomial. The square root of 2 is allowed because we can take the square root of 2 and get a constant. That would also be considered a polynomial. As I mentioned before, we have different types of polynomials, and they can have multiple terms. The most common types of polynomials are monomials, binomials, and trinomials. Those are the special names that you'll hear us use. A monomial has one term. A binomial has two terms. Notice 5x is the first term and 1 is the second term. A trinomial has three terms. The 3x is the first term, the 5y squared is the second term, and the 3 is the third term. An easy way to remember those is to think about bicycles. Mono is a single-wheeled cycle, bi is a two-wheeled cycle, and a tri is a three-wheeled cycle. So that's an easy way to remember those prefixes to help you remember how many terms there are in each type of polynomial. If you have a four-term polynomial, we call that a quadrinomial, and a quintinomial is a five-term polynomial, but those names are not often used. Generally, when we get greater than three terms, we just go back to the general term of polynomial. We only use these terms, specific terms, monomial, binomial, trinomial, and then we advance on to polynomial. You'll really rarely see these terms right here of quadrinomial and quintinomial. The next characteristic of polynomials that we want to talk about is the degree of a polynomial. We have two types of degrees that we want to specify. We want to talk about the degree of just the monomial within a polynomial, and then we're going to talk about the degree of an entire polynomial. So if we're looking at the degree of the monomial, we're talking about just the sum of the exponents of the variables. So let's take a look at a couple of monomials and find their degree. If we have a monomial and we want to find the degree, we merely add up the exponents that are on the variables, and that is the degree of that monomial. So if we take a look at 5x squared, we look at the exponents on the variables and add them up. In 5x squared, there's only one variable and one exponent, so the degree of 5x squared is 2. That was pretty easy. 4a to the fourth b cubed c. That one's a little different. We have an exponent of 4, an exponent of 3, and the c has an exponent of 1. Now that is one that everyone needs to watch out for. Most people forget this exponent right here. So make a mental note to remember that when you don't see an exponent there, there's actually an exponent of 1. So if we add up all of our exponents there, we have 4 plus 3 plus 1. So our degree of this monomial is 8. The degree of any constant term is 0. Now why is the degree of a constant term 0? Well, the degree of a constant term is 0 because the degree is the sum of the exponents of the variables. Well, if there are no variables, then we have no exponents of which to take the sum. So the degree of a constant term is always going to be 0. Now, what do we do if we're focusing on a polynomial, which is the combination of several monomials? Well, we calculate the degree of each individual term of each individual monomial within the polynomial, and then we look at the largest value that's there. Whatever the largest value that is there, that is the degree of the overall polynomial. So let's try a few. Take a look at this first polynomial, 8x squared minus 2x plus 7. List the degree of each individual term. So first let's look at the degree of the 8x squared. 8x squared has a degree of 2. 2x has a degree of 1. Remember, if there's nothing there, it's a 1. And the degree of the 7 is 0. There is no fourth term, so we don't even worry about that. So what's the largest value found in this polynomial? Well, it's 2. So the degree of this polynomial is 2. How easy was that? Pretty easy, right? So let's look at the next one. The degree of y to the 7th, 7. The degree of 6y to the 4th is 4. The degree of 3x to the 4th, m to the 4th. I need to add my 2 4's. So let's just write down that. That's what we're doing there. We're going to get 8. And there is no fourth term again. So the largest value we found in the second polynomial example was 8. So the degree of that entire polynomial is 8. Let's take a look at the last one. The degree of this x, even though there's no exponent shown, is 1. The degree of the 3, there's no variable, so there's no exponent at all, is 0. There's nothing in a third term or a fourth term. So the largest degree found in this polynomial is 1. And that's how you find the degree of a polynomial. So you try one. What do you think the degree is of this polynomial? Go ahead and pause the video and give it a try. See what you find. Well, did you get that the degree was 5? The first term has a degree of 5. The second term also has a degree of 5. So the largest value there is 5. The degree of the entire polynomial is 5. As with most things in algebra, there's a specific order in order to keep things neat, tidy, and easily legible. Polynomials are generally written either in ascending or descending order, and that is generally specified. Remember what ascending order is? It's going from small to big. And we refer to the exponents to determine what the order is. Descending order, that means we go from big to small. And we look at the exponents. So let's try one. Let's put this polynomial in descending order. We look for the largest exponent because we're going in descending order. We're going to put the largest exponent first and then go to the smallest exponent. So our largest exponent in this polynomial is x to the 4th, and it is positive. So I'm going to start with positive x to the 4th. My next exponent is x squared. So I'm going to take that entire term and its sign, and I'm going to write it. I'm going to look for my next exponent, which is x to the 1, 8x. And then my term without a variable always goes on the end. So now I have my exponents in descending order. 4, 2, 1. There is no exponent of 3, so I don't need to put anything in that place. Notice that I kept the correct sign with each term. The minus 3x squared, the plus x to the 4th, and the minus 4. It's very important that you pay attention to which sign is with each term when you're moving it around. In this polynomial, I have x's and y's to look at. Notice that my directions say put in descending order in terms of x. That means that when I'm putting it in descending order, I only look at the exponents that are on my x's. It doesn't matter what's on my y's. So I'm going to focus on the x term of each term. This one doesn't have an x term, so that one's going to go on the end. So I look for my largest exponent on an x term, and in this case it's going to be this term right here. So I'm going to start with negative 6x cubed y squared. My next term is going to be my x squared term, which is positive 12x squared y cubed, then minus 2x plus 3y. And that's how you write in descending order. You would do the same thing to put in ascending order, except that you would order your exponents from small to large. Mostly, though, we write in descending order. So now that we can identify, classify, and arrange polynomials, let's work on adding and subtracting polynomials. Subtracting polynomials is really no more than lining them up and combining all of the like terms. Now, if you recall, like terms are just terms that have the same variables, that have the same exponents. Remember, just having the same variable is not enough. They also have to have the same exponents in order to be considered like terms. So identifying the like terms in this polynomial, we would see that 2x squared is a like term with x squared, and no other terms are like terms with those two terms. So these two terms are like terms. The other set of like terms would be negative x cubed y squared and negative 2x cubed y squared. Those are like terms. The 4xy is not a like term with these two terms, even though they have an x and a y variable, because the xy on the 4 coefficient do not have the same exponents. That is not a like term with any other term in that polynomial. When you combine like terms, remember we only combine the coefficients, but do not change the powers of the variables. For example, if I were going to combine the like terms 2x squared plus x squared, I would combine 2x squared plus x squared. Recall that there is a coefficient of 1 in front of that. That would become 3x squared. I do not change the x squared to x to the 4th. It just stays the same. Now, to make the process of adding and subtracting polynomials easier, I would like for you to grab a few colored highlighters, because I have a trick to make this process go a little faster for you and a little easier and help you keep it organized. So let's get your colored highlighters together and give one a try. Here are 3 polynomials, and we're going to subtract and add all at the same time. We have negative a squared plus 3 minus the polynomial a squared minus 1 plus the trinomial 7a squared minus 3a plus 5. The first step is to get rid of all of your parentheses. Now the way you do that is just distributing the 1 or whatever value is in front of your parentheses, just like you are used to doing. So I have inserted a 1 here just as a placeholder to show you that it's there. Now the trick is, when you see the minus sign, remember that that's a negative 1 there that needs to be distributed. So what's that going to do to your signs that are inside of the polynomial? You're going to be multiplying everything times a negative 1, so you need to change the sign of everything inside of parentheses. So this is not new information for you. You know how to distribute a 1 through parentheses. So let's distribute. When you distribute a negative 1 and do your multiplication, or a positive 1 and do your multiplication, you will just write down the product of those values and get the result. So in the first polynomial or binomial, you don't have a 1. I didn't put 1 there, but there it is. 1 times negative a just gives us negative a. 1 times positive 3 gives us positive 3. Negative 1 times a squared is negative a squared. Negative 1 times negative 1 gives us positive 1. Positive 1 times 7a squared is positive 7a squared. Positive 1 times a negative 3a is negative 3a. And positive 1 times positive 5 is positive 5. So now we have a list of terms that we can look for like terms and combine. Here is where your colored highlighters are going to come in. Use the different colors to mark the terms that need to be combined, making sure that you also mark the sign that is in front of that term as well. So take a look. I'm going to start with the a squared terms. I'm going to mark each of the a squared terms in yellow. The negative a squared here, the negative a squared here, and the positive 7a squared here. Notice that I also marked the sign that was in front of the a squared term in each case. After that, I'll go through and I'll mark each of the terms that don't have a variable. It doesn't matter which term you mark in which order, I just happen to go in this order. I started with the a squared terms, then I went to the non-variable terms. I think I went in that order because that's the order I came to them in a row. I started with the squared term and then I came to terms that didn't have a variable. I think that's why I went in that order. So the next term that I'm going to mark is going to be the term with no variable at all, and I'm going to mark it in blue. So notice how all the different types of terms have a different color, and I marked the sign that was in front of that term. Once I have each type of term marked, then I can combine all of the similarly colored terms. I'm going to group all of the a squared terms, or all of the terms that are grouped in yellow. I'm going to group them over into a group. Then I'm going to all of the colors, the ones that are grouped in green, or all of the terms that have no variable, and then the terms that have an a. All that's left to do then are combine like terms. When I combine my a squared terms, I have negative 1a, and positive 7. That combines to be a positive 5a squared. My negative 3a doesn't have anything to combine with, so I just write it into my polynomial. Positive 3, positive 1, and positive 5 combine to equal positive 9. My polynomial is completely simplified when I no longer have any like terms that can be combined. So there are no like terms left in this polynomial that can be combined. So the result is 5a squared minus 3a plus 9. You've completely simplified and you've combined three polynomials. You started with this large polynomial combination problem right here, and you've simplified it down to this simple trinomial right here. Let's try another one. Let's subtract the trinomial, or add the trinomial 5x squared plus 5x minus 6 plus 3x squared plus 3x plus 14 minus 8x squared minus 16. Remember, first, remove the parentheses by distributing any ones that are on the outside. When I distribute the ones, here is how it results. In the first set, it's positive, so that distributes and I get 5x squared plus 5x minus 6. It's a positive one, so essentially I just drop the parentheses. In the second set, it's a positive one again, so again, I'm essentially just dropping the parentheses. Positive 1 times 3x squared gives me 3x squared. Positive 1 times 3x gives me 3x, and positive 1 times 14 gives me 14. Now here's where some changes are going to be made. Negative 1 times 8x squared gives me negative 8x squared, and negative 1 times 16 gives me positive 16. Now you want to grab your colored highlighters. You got them ready? Let's start with the terms. I'm going to highlight all of my x squared terms. Just ignore this little green blip right here. That was left over from when I was copying. All of my x squared terms are going to be highlighted in blue. You can highlight them whatever color you like. From there, I think I'll highlight my x terms. I'm going to highlight those yellow. Again, ignore the little green mark on the right. All that's left to highlight now are my terms with no variables. I'm going to highlight those green. That's where my green comes in. Now that I've got all of my different terms highlighted, I can combine all of the different colors. Each of the like terms are distinguished by color, so group them. My x squared terms are distinguished by blue, so when I group them, I bring them down, remember, along with their specific signs. I have a typo there. That should say 3x squared and not 8x squared. My x terms, 5x and 3x, terms, -6 plus 14 plus 16. I'm going to have to keep correcting that with every screen. So, look at what happens. I end up with 5x and 3x, which gives me 8x, and a -8x squared. Those cancel out to be 0x squared. 5x and 3x give me 8x, and -6 plus 14 plus 16 give me 24. I take off the 0x squared because that's nothing. I don't need to write that. And my final result is 8x plus 24. So I've combined this huge combination of terms here down into a simplified version of 8x plus 24. Wasn't too bad, except for my mistake here with my typo. But it just wouldn't be me without at least one mistake, would it? Now you try one. Go ahead and pause the recording and see if you can eliminate the parentheses by distributing the -1. Then use your highlighters to highlight the like terms. Just make sure you also highlight the sign in front of the term, and then combine your like terms and see if you come up with the correct result. Okay, how'd you do? Could have done. The -1 is in front of the second polynomial. When we distribute, you should have gotten minus 3x to the 4th y squared plus 5x cubed y plus 6y minus 8x. I used my colors to highlight my like terms, and then I combined. Here are my x to the 4th y squared terms, my x to the 3rd y terms, my y terms, and then I had a single term that had an x. When I combined all of those terms, my final result was 2x to the 4th y squared, 11x cubed y, minus y, minus 8x. So let's summarize. A polynomial is a combination of monomials held together by addition or subtraction. And remember, no division by a variable is allowed. We like to organize them by writing them in descending order based on exponents. There are 3 common types of polynomials: monomials with 1 term, binomials with 2 terms, and trinomials with 3 terms. Adding and subtracting them is really no trouble. We simply organize them and combine like terms, making sure we pay close attention to the signs. Aside from that, that's really all you need to know from this lesson.